Okay, for this video, I want to continue our conversation with multiplying polynomials. So, where we left off, we were multiplying these conjugates here, this difference of squares. And let's do this example. So we have 15 times 15. Well, what's that? That's 225, and then x times x is x squared. Then we have 15x times 6. Well, that'd be 60 plus 30, so that's 90x. Negative 6 times 15x, so that'd be negative 60 plus 30. That's negative 90x. And then negative 6 times 6 would be negative 36. Okay, can we combine any cross terms? I have negative 90x, 90x, so these cancel. 225 x squared minus 36. This would be my final answer. Okay, let's go on. So another example would be 11y minus 10 times 11y plus 10. These are conjugates because they have the opposite sign in the middle. So this is going to represent an example of difference of squares. Okay, so 11 times 11, well, it puts the middle number, puts the next number in the middle, so 121y squared. 11 times 10, well, that's going to be 110y. Negative 10 times 100, or no, I'm sorry, I'm saying the answer. Negative 10 times 11 would be negative 110y. And then we have negative 10 times 10, well, that's negative 100. I noticed that these are equal and opposite, just as we might suspect, so those are canceled because they reduce to 0, minus 100. This would be my final answer. Okay, so I hope this helps when you're doing it. Now again, there's nothing in this problem that you need to understand this concept, but I think it's good to know where things are going while you're kind of learning this. So while you're distributing this, you can say, okay, well, there seems to be a formula here. And when we try to do problems backwards, which is factoring, when you try to go this way, it's very helpful if you have that understanding. Okay, so let's move on to our last example of these multiplying polynomials, and this is the sum of cubes. And this would probably be the most difficult, both to distribute and difficult to understand because it's so it has a complicated structure. But when I say sum of cubes, I have a cubed plus b cubed, and they're added, so that's the sum of cubes. And then they have this structure. But let's just go ahead and try this problem, and then we'll be able to see what's going on. So first I have 6a times 36a. Well, what's that? 6 times 3 is 180. 6 times 6 is 36. So that'd be 216a cubed. Then I have 6a times negative 6ab. So that'd be negative 36a squared b. Then I have 6a times b squared, so plus 6ab squared. Okay. Now, since this is such a long problem, I'm actually going to put the next terms lower here, so hopefully that won't be confusing for you. B times 36a squared, so that's 36a squared b. And then b times negative 6ab, negative 6ab squared. And then b times b squared would be b cubed. Okay, what did we get? What can we compute? I'll put a little plus sign here. So it looks like we only have one a cubed. So that would be the a cubed term. Negative 36a squared b, positive 36a squared b. These are going to cancel. Then I have 6ab squared minus 6ab squared. These cancel. So I'm just left with this term and this term, plus b cubed. This is what I mean by sum of cubes. This is equivalent to 6a cubed plus b cubed. Okay, this is the final answer, but I just want to demonstrate that it has this structure. Okay, well, I hope that's not too confusing. Right now, we're just understanding how to distribute these, But later, when we try to factor, we'll have to go backwards. We'll have to understand that this could be represented in this way. Okay, let's do some more examples. Now, let's try difference of cubes. The only thing that's different is this negative sign here and this plus sign here. And so I wrote out the formula there, but that's the only difference. But again, we're just going to distribute and see what happens. 2 times 4 is 8, so we got 8x squared. 2 times 10 is 20, so we have 20x squared. I apologize, this should have been cubed. I just now see that. 2x times 25, well, that's going to be 50x, okay? Negative 5 times 4 is going to be negative 20x squared. Negative 5 times 10 is negative 50. Then we have the x. And negative 5 times 25, that's going to be negative 125, 5 quarters. Okay. Can I combine anything? I have 20x squared here, negative 20x squared here. That's going to cancel. 50x, 50x, that's going to cancel. So my final answer is 8x cubed minus 125. And that's the final answer. Okay, well, that is in the form of, again, this is the final answer, but that is in the form of 2x cubed minus 5 cubed. So this is the difference of cubes. Okay. So let's try this example. Is this the sum of cubes, difference of cubes? Well, there's a minus sign here, so it's probably difference of cubes. But let's see. 10 times 100,000, you just add the 0. X cubed. 10 times 10, well, that's 100. X squared. 10 times 1, that's 10x. Then minus, I'm going to put a minus sign here. Minus 100 x squared minus 10x minus 1. Okay, what can I combine? I have 100x squared minus 100. I have minus 10, positive 10. I'm left with this term and this term. So 1000 x squared minus 1. That's my final answer. Is it true that this is the difference of, oh, this should have been cubed. I apologize. I wrote squared. I think I even said squared. This should be cubed. It was here, and when I transferred it down for some reason, I put a 2. So this is the difference of cubes. Okay, this has the structure of 10x cubed minus 1 cubed. 1 times 1 times 1 is 1. So that does have that structure, okay? But right now we're just learning how to distribute. Okay, here are some bonus problems that there is no specific structure to them. They're just kind of random problems. They correlate with things we've learned, but they're kind of on their own thing. So for this one, I'm going to have to kind of break this up, and then I'll have to distribute this separately. Okay, so let's do that. 3y minus 2, 3y minus, why did I write 1? I should write 2. Okay, and then I'll copy this down. 2y minus 1, 2y plus 1. Well, if you recognize what this is, it's just like what we learned in part 2, where it's the perfect square, so you can see what the structure is. So you could use the formula to solve it if you want, or you can distribute term by term. I'm going to use the formula. So the first term is squared, so that's 9y squared. Then the last term is squared, so negative 2 times negative 2 is positive 4. And then we want to write 2 times 3, which is 6, times 2 is 12, so that's negative 12y. Okay, so that's the first part. That's this part. Now, what about this? This looks a lot like difference of squares, which we just talked about. They are conjugates of each other, right? You have 2y, 1, 1, but they have the opposite sign in the middle. So this is most likely going to be 4y squared minus 1, difference of squares. Okay. Now, you can just distribute that and you'll get the same thing, but sometimes it helps to identify things. All right, let's just subtract. So I have a y squared term here, a y squared term here, so I have 9 minus 4. That gives me 5. I have a y term here. There's no y term here, so I have negative 12y. I have 4 minus minus 1, so that's plus 5. Okay, and so that's the final answer for that question. Again, it uses things we've already learned, but, it's not exactly a one-to-one thing that we've done. Again, I hope this helps. Please reach out if there's anything that's confusing, but I'll see you in the next video.